Now let us consider some cases to make our understanding clear. Consider case 1, when the line charge is of infinite length. Wherever we will consider point P, the upside line will be plus infinite and the downward it will be minus infinite. So in that case, if the line charge is of infinite length and remaining conditions remain same, charge density and everything remains same, in that case the point P that is considered here will make what will be alpha 1 and alpha 2, because these two terms are unknown only. So what we can say here, this is the perpendicular length and the first end is A, the second end is B, that is at infinite. This is alpha 2, okay, and this is alpha 1. From here we can say from this point to the one end is alpha 1, from this point to the another end is alpha 2. Okay, alpha 1 is moving in this direction and alpha 2 is moving in opposite to that. Here one assumption has been taken that we have considered anti-clockwise the angular rotation as positive. In that case, the maximum value, if this length changes to infinite, then alpha 1 can be maximum. In that case, alpha 1 can be pi by 2 if this length tends to infinite, and if this length tends to infinite, then alpha 2 tends to minus pi by 2. Hopefully it is clear. In that case, electric field intensity due to infinite line charge will be equal to the, put the value of alpha 1 and alpha 2 here, cos alpha is 0, 0, so there will be no AZ component. Now put the value here, cos alpha 1 will be 1, here it will be, put the value of alpha 1, this will be 0, put this value here, you will get minus rho L divided by 4 pi epsilon rho, sin alpha 2, sin minus 90 will be minus 1, minus sin 90 will be 1, multiply in the direction of arrow. So finalizing this, we can say minus 2 will be multiplied here, rho L divided by 2 pi epsilon rho arrow. Okay, so this is the electric field intensity of infinite line charge, infinite length line charge will be in the direction of rho and with amplitude this. Okay, now let us try to understand this, how much we are accurate towards our result. Consider any point, for example A. The electric field intensity at this point P from this charge will be in this direction. Consider E1. Okay, it will have two components, one will be horizontal, another will be vertical. So its projection on the x-axis On this axis will give you E1 component in this direction, E1 component in this direction. Consider another point that is at the same length from the perpendicular at the top. It will give you, for example, consider it E2. Since it is at the same position in another direction, so the component of this will be this and this. The component of this in this direction and the component of this in this direction will be cancelled out, and the component of this in this direction and component of this in this direction will be added out. So total field will be 2 times this, 2 times the component of this in this direction. Okay. So if you will take, you will consider any point, its component here, its component in vertical, consider here, its component here, its component vertical. So vertical components will be always die out, cancelled out. The horizontal component will be there. In this way, this direction is the radial direction. Okay, vertical direction is z direction. However, this direction is radial direction. So there is no component in this z direction, only the component in the direction of arrow are present there. That is verified from here. So this is the electric field intensity in the case when line charge distribution is there of infinite length. Now let us consider case 2. In this case, consider that this line, this point is at the middle of this line, point of interest at which we want to find the electric field intensity is at the middle of the line charge. This is the point. This is our charge distribution of density rho L. If it is at bisector of this line, then we can say at perpendicular bisector. P is at perpendicular bisector. In that case, what will be, here it is alpha 1, what will be alpha 2? It is isosceles triangle, so it will be alpha 1 again. So alpha 2 will be equal to the alpha 1, however with opposite sign. So alpha 1 is okay, alpha 2 will be minus alpha 1. Okay, now put it there in the final form. If you will put it there, then okay, write the formula once again to make the things visible. 4 pi epsilon rho minus cos alpha 2 plus cos alpha 1 in the direction of AZ. Again, here AZ component must not be there according to this analysis. So let us see, plus sin alpha 2 minus sin alpha 1 arrow. Okay, I have just written this formula once again. Now we have to put value alpha 1 and alpha 2 in terms of either alpha 1 or in terms of alpha 2. So let us put in terms of alpha 1. So alpha 2 should be equal to the minus alpha 1. I am just erasing here and putting the value minus alpha 1, and we know, okay, come to here, it will be minus alpha 1. Okay. In this condition, alpha 2 will be minus 1 alpha 1. So we have taken the value of alpha 2 from here and here. We replace them by minus alpha 1. And we know cos minus theta will be cos theta. So according to that, it will be minus cos alpha 1 plus cos alpha 1. It will be equal 0, cancelled out. So again AZ component will be absent. Sin minus alpha 1 will be minus sin alpha 1. Alpha 1 and minus again sin alpha 1. So it will give us times 2 in the direction of rho. So if we will simplify, then we will find 4 pi epsilon rho minus and minus, it will give you plus 2a rho. And if we will further simplify, it will give you 2. So the value and sin alpha 1. Sin alpha 1 is missing. So this is the electric field intensity when the point of interest is at the perpendicular bisector of the line charge. In this case and in this case, there are no vertical component of the field. So Z component is absent, only rho component is available there. So consider now case 3. In this case, assume that you are at the end, one end of the line and second end is at infinite. Consider it as at infinite. So you can say case 3, you are at one end. Observer, you can say observer is at minus infinite. So you are here, it is minus infinite, point P is here, okay, it is moving onward. So in this case, what will be alpha 1? Consider it. You are at the end of this, because this is the negative direction of the line, this positive direction of the line. You are at the end of this. So what will be alpha 1? Alpha 1 in that case, if you find assume this condition, then alpha 1 will be 0. And what's about alpha 2? Alpha 2 will be, you are at this end, so and this end will be at the end. So it seems to be that you are seeing vertically, so alpha 2 will be minus pi by 2. Put the value here and try to find the electric field intensity. So let us try to find E will be equal to the, put the value here. So it will be minus rho L divided by 4 pi epsilon rho minus cos alpha 2 minus cos alpha 2 plus cos alpha 1 in the direction of AZ. Consider it, there is no charges in this direction. This is the end at minus infinite, you are present there. So this there is no component in this direction. So in that case, the vertical component of this will be, suppose any point here, field will be in the direction, two component will be here, one will be horizontal, one will be vertical. To compensate this vertical component, a charge should be here, must be here, but there is no charge. So in this way, what we can find, AZ component is not possible to eliminate in this case. So possibly Z component should be here. Let us try to find. Okay. Plus sine alpha 2, sine minus pi by 2, minus sine alpha 1 into arrow. Okay, carry on. Minus, I think it is visible, minus rho L divided by 4 pi epsilon rho. It will give you 0, it will give you 1 AZ, it will give you minus 1, it will give you 0, minus arrow. So this is the electric field intensity in that case when observer is at one end, at negative end of the line charge. Hopefully it is clear to all of you. This is the end of today's lecture. Thank you very much. So students, please let us try to solve few questions based on line charge density. The first problem is given here. An infinite line charge of density 20 nanocoulomb per meter lies along z-axis. We have to find the electric field intensity at this point. So directly coming to the particular this problem, let us just recall our derivation that we have done yesterday. For electric field intensity in case of line charge was rho L charge density, line charge density, divided by 4 pi epsilon naught until or unless the material is given, the rho, and inside the bracket it was minus sine alpha 2 minus sine alpha 1 in the direction of radial vector arrow plus cos alpha 2 minus cos alpha 1 in the z direction. I think yes, this was the formula that we have derived for electric field intensity at any point due to line charge. So now let us try to find the electric field intensity in this case. For that purpose, let us visualize the problem. The line is placed along the z-axis. So consider this z-axis, and this is, if this is z, to bring z we have to do cross product. This is, if it is positive direction, then x should be here, xy, cross product will give z as z to us. Now the charge density is 20 nanocoulomb per meter. Okay, it continues. Now let us allocate the point at which we are interested to find electric field intensity. That is, point is in the direction of x, 6 point in the direction of y, coordinate will be somewhere here, and in the direction of y, z, in the direction of z it is 3. So the point of interest P is 683. This is the point of interest. Okay, P. Now we have to find the electric field at this point. So just try to find the perpendicular distance from this point to this line charge. That will be parallel to this plane. Parallel to this plane. This is rho, by the way, this is rho, and this is point P, and the angle, since it is infinite, so this is alpha 2, that is minus pi by 2, because assumptions has been taken that in the clockwise direction it will be negative, and this will be at minus infinite side, it should be alpha 1, that will be pi by 2. Now for particular this problem, we have this type of argument where alpha 2 is minus pi by 2, alpha 1 is pi by 2, and rho is, just try to find the rho, then the coordinate of this is rho is this length in the xy plane, so it is rho. How much it should be? This coordinate is 3 in the z direction, so it should be 0 0 3. So if we are interested to find the rho, then this minus this square, this minus this square, and this minus this square, that will give this length to us. So it should be equal to the under root 6 square plus 8 square, and the direction of this will be arrow direction, like that. I think that is 10, the direction of rho. So overall, the required parameters for finding the electric field intensity at any point, that is rho, that is 10, alpha 2 minus pi by 2, alpha 1 pi by 2, and rho L is already given. So for particular this problem, try to find E is equal to rho L 20 nano divided by 4 pi epsilon naught. For time being, don't put the value. Rho is 10, absolute value of this is 10, in the direction of minus, sine minus pi by 2 will give you minus 1, minus sine pi by 2 will give you 1. In this way it will give you minus times minus 2, it will be 2, in the direction of rho, plus cos minus pi by 2 will give you 0, and cos pi by 2 will give you 0. So it will be 0 Az. Probably it is clear. So if you will put the values, then you will find 1 by 4 pi epsilon give you 20 into 10 to power minus 9. 1 by 4 pi epsilon naught will give you 9 into 10 to power 9, that is known value, and this will give you 2 in the direction of rho divided by 10. Probability is okay. So now this will be cancelled out, this will be okay. 18 into 2, that is 36 arrow. So this is the final electric field intensity at point P due to this infinite line charge. Okay, so in this way electric field intensity at point P will be equal to the 36 arrow Newton per coulomb. Now let us do another problem, that is a line charge is distributed along z axis between z is equal to plus minus 4 meter with a uniform line charge density 10 nanocoulomb per meter. Find E at this point. So the formula is same, just we have to put the values in this formula. This is the standard formula for that. So first draw the image that can be a replacement of this image, this problem. This is z axis, the charge is distributed along the z axis. this, and that is plus 4 minus 4. Here will be origin. It should be, if this is y, then if this is z axis, then this should be x and this should be y. Now we have to find this is the distribution of the charge, and rho L is 10 nanocoulomb per meter. E at 200, it means it is at x axis because this and this coordinate is 0. So that is at length 2 unit. So 200 will be this point, that is P. P point is here. Now we have to find the electric field at this point due to this line charge distribution. So let us try to make the image more clear. This is our charge, and here is x at the length 2 unit. This is 4 unit, and 4 unit length is always positive, so 4 unit. This is 0 0 0, and this is our 4 0 0 4 0 0 minus 4. This is 2 0 0. This length will be rho, that is 2. This is 4, and this is our alpha 2, and this will be alpha 1. Now put the value of alpha 1 alpha 2 here. E will be rho L 4 pi epsilon naught rho minus, this is 2, this is 4, so sine alpha 2 will be perpendicular by hypotenuse, so it should be 2 square plus 4 square, that is 20. So 4 by 20, okay, and since it is considered as minus, so it should be minus 4 by 20, and minus sine alpha 1 will be plus 4 by 20 in the direction of arrow, plus cos alpha 2 will be 2 by 20, because cos minus alpha is cos alpha, minus cos 2 by 20. This is not considered as minus length because that is length, so it will be 4 by 20. Anyway, it is in the direction of Z. Okay, this thing will be cancelled out. The remaining term will be rho L by 4 pi epsilon naught rho 2 times 4 divided by rho 20 in the direction of rho. And which one is radial vector? Radial vector will be along the AX. So rho will be along the AX. You can write it here. 10 into 10 to power minus 9 1 by 4 pi epsilon naught can be written as 9 into 10 to power 9 into 8, rho is 2 into root 20. It will give you full, so it can be written as okay. When you will solve it, then it will be cancelled out. 2 will be out from here, so inside will be 5, here will be 4, 2, 180 divided by root 5, that is Newton per coulomb. It should be in the direction of AX.